Okay, so in today's lesson, we're going to talk about acceleration. So, what is acceleration? Well, acceleration measures how quickly the velocity changes. Remember, velocity is speed with a direction, so we can change our speed, increase or decrease the speed, or our direction. When do we feel acceleration? Because we do feel acceleration. So let's think about this. If you're in a car or a motorcycle and you're stopped at a stoplight and then you just when the light turns green, you speed up. You can feel acceleration then. What do you feel? Well, if you're on a motorcycle, you probably feel your hands having to grip tighter because you're being pulled backwards a little bit. Or if you're in a car, you feel like you're being pushed back into your seat. Okay, similarly, when you are going fairly fast and all of a sudden the light turns to yellow and red in front of you and you hit your brakes pretty quickly, you will slide up and into your handlebars, or if you're in a car, you might even get caught by your seatbelt. And then over here we have someone who's going over a ramp or a hill and they kind of go up and then come down. You feel acceleration then as well as you're changing direction. Also in a car or on a motorcycle, if you go down and you go around a curve, you'll feel acceleration as you'll want to continue going this way. And you might feel either, depending on which side of your car you're on, either pushed into the door or pushed towards the center of the car. So, that being said, let's talk about now what does it mean to have an acceleration of 5 meters per second per second? That's what we have here. What that means is that every second your speed is changing by a positive 5 meters per second. So, for example, if you're starting from rest, so you're starting by going 0, after 1 second your speed will have increased by 5 meters per second. So 0 plus 5, after 1 second, you'll be going 5 meters per second. After 2 seconds, so now we've been going for 1 second, another second later, we need to increase by another 5 meters per second, so then we will add another 5 meters per second. We are now going 10 meters per second. And another second later, we'll be going 15 meters per second. We are increasing by 5 meters per second for every second that goes by. So what is our formula here? Well, we've got our symbol is the letter A for acceleration. And what it is, it's the change in velocity. Remember, change in is represented by the Greek letter delta. So it's the change in our velocity divided by the change in time. So, all right, so you see the delta. That means the change in velocity. What that means is we need to take the final velocity and subtract the initial velocity to get our change in velocity. See the subscripts F and I, they stand for final and initial. The change in time means the same thing. Take the final time minus the initial time. But we don't really use that very often because, well, we usually are looking for the change in time, how long it takes to do something. So quite often we just leave it delta t. Now, this equation, acceleration equals a change in velocity or the change in time, often is written another way by substituting the final minus the initial in for the delta v and then solving. So let's do that. Acceleration is equal to the final minus the initial divided by the change in time. Now we want to solve for the final velocity. To do that, the first thing we need to do is get rid of the delta t by multiplying both sides by the change in time. So we have the acceleration times the change in time is equal to the final minus the initial. And I'm trying to solve for the final, so I need to add the initial to both sides. Pretty simple. We'll get the final is equal to the initial plus the acceleration times the change in time. And this equation is one that we use quite often. It's simply derived from the first one, where the acceleration equals the change in velocity over the units. Well, we just looked at it, meters per second per second. We usually write that like this, meters per second squared. This is miles per hour or miles per hour squared. You could mix and match your time units. We don't typically see that, but occasionally in some areas we do use this. So you could have miles per hour per second. So you could increase by 5 miles per hour every second. So as you're getting on an on-ramp, okay, you could be increasing by 5 miles per hour every second, things like that. Most of the time in this class, this will be our unit for acceleration. How does direction affect motion? Well, let's look at this. If we have a positive velocity and a positive acceleration, what's going to happen to us? Are we going to speed up? Are we going to slow down? Well, let's go back and think about velocity. Velocity has to include a direction. So this is what the positive is telling us. Remember, if something's positive, we say it's either going up or to the right. So for this example, we're just going to say it's going to the right. Okay? And we're going to just give us an example. We're going to say we're starting with 5. Okay? And we're going to say our acceleration is 2. It's a positive 2. So that means we're starting with 5 and we're adding a positive 2 to that. So we're adding a positive 2 to that. So we're going to end up going 7 after 1 second. So after 1 second, we're going to go from 5 to 7. So what's the effect? We are speeding up. All right, so let's go ahead. What if we have a positive velocity? So we're heading to the right, and we're going to say we're starting off at 5 again. And our acceleration is negative, so we're going to make it a negative 2. So acceleration is working in the left direction. So it's a negative 2. So 5 plus negative 2 gets us a 3. So that means that after this second, we're going to be going 3 meters per second towards the right. So we're still going to be going in the right or positive direction, but we went from 5 to 3, which means we just slowed down. All right. Then we can look at this. Let's say we are starting with a negative velocity of 5. Well, that just means we're going to the left at 5 meters per second, miles per hour, whatever our units are. So we're going to the left. Same magnitude, just going the other direction. So we're going the negative 5, but our acceleration is positive, so it's acting towards the right. And it's a positive 2, so negative 5 plus 2 is negative 3. So that means that we're ending up going 3 meters per second to the left. So what happened here? We went from 5 to 3. We actually slowed down. The negative's just telling us the direction. So we slowed down again. Looking at this last one, so we're starting out going to the left. We're going to say 5 again. And our acceleration is towards the left at negative 2. So negative 5 plus negative 2 is negative 7. So we're going after a 1 second, negative 7. Well, that means we're going faster in the direction to the left. So we actually are speeding up. Take note. Both positive, sped up. Both negative, sped up. Positive and negative, slowing down. Positive and negative, or negative and positive, slowing down. So when our velocity and our acceleration are acting in the same direction, we're going to speed up. When they're acting in opposite directions, we will slow down.